Hi guys, so I want to talk about the lessons. I'm going to start recording these. If they're long, you can fast forward through them, go back and look at them, whatever you need to do. I am going to post the notes, the unfilled out notes, so you can print them off if you want and fill them out as you go along. So we will go there. Homework will be all done in either Delta Math or in in Canvas through Nearpod. Just depends, or maybe a combination of both. It just depends on the lesson and what we're doing. So that is what's going to happen with the homework. So here we go. We're going to start with 9.2 inverse functions. Our essential question for the day is, what are inverse functions and how are they found? So here we go. We're going to define inverse function. First, in order to define, we're going to define a one-to-one function. The first thing we need to define is, we're going to define actually what a function is. And I know you guys know what a function is. It's for every x there is exactly 1 y. Okay, so now we're going to define what it is to be a one-to-one function. Okay, that means for every y, there is exactly 1 x. So for it to be a one-to-one function, it has to be both a function and then, so it has to meet the function definitions. So for every x, there's exactly 1 y. And then for it to be one-to-one, it also has to meet the reverse that says for every y, there's exactly 1 x. So we have some examples. A is a function because for every x, there is 1 y. So yeah, it's a function. But it's not one-to-one because, it is one-to-one because every single one of the x's has only 1 y. So that's a one-to-one function. B is a function because for every x, there is 1 y. Okay? But if you can see here, right here, these two x's, this 1 y has 2 x's. So it doesn't meet the one-to-one function. It meets the definition of a function, but not the definition of a one-to-one function. So from a graph, how can we look at it? So C here, look, what we do to test for this, to test for a function, we do the vertical line test, right? So as I pass through the vertical line, if it only touches in one place, it's a function. Well, to test if it's a one-to-one function, I also want to pass a horizontal line test. Wow, I'm speaking really well today. Horizontal line test. So it has to pass both. It has to pass the vertical line test to be a function, and then it has to pass the horizontal line test to be a one-to-one function. So that's why C works, but D doesn't. Notice right here in my horizontal line, it has 2 x's for that 1 y, so it is not a one-to-one function. It is, however, a function. I hope that helps clarify the definition of a one-to-one function. We're going to go ahead and move on now. And we're going to define what an inverse function is. So an inverse function is denoted by f inverse of x. So we're going to put the little -1, subscript of -1, superscript of the -1 up here, right here. That means it's an inverse function of f of x. And then how do we find an inverse function? How do you find an inverse function? Okay, pretty easy. We exchange the x and y, then solve for y. Okay, we're going to have a couple examples of that, and I'm going to show you what I mean. So hopefully you can get it. And I'm just going to slide up just a little bit because we have two examples right here. They want us to find the inverse function. Okay, so see it says, sorry, find the inverse function. Now I'm going to make it a little bit bigger here so we can see what we're doing. So first of all, I see the x, my x is here, but where's the y at? Right, another word for y is f of x. So this is y equals 2x minus 3, right? So how do I find my inverse function? It says I take my x and my y and I exchange them. So that would be x equals 2y minus 3. So I just took the x and put it where the y was, and took the y and put it where the x is. And then it says solve for y. So I have to get y by itself. So I'm going to add 3. Then I get x plus 3 equals 2y. And then to get y by itself still, I have to divide by 2. So then y is by itself, but I don't want to put y because I'm not looking for y, I'm looking for the inverse. So my function was f, so I'm going to say f inverse of x. So I know that I was looking for the inverse. So I know this is the inverse of my function. Okay? The inverse of my function is x plus 3 divided by 2. And I'm done, and that's all. Okay? But I need to make sure that I put in my f inverse of x. Okay? We're going to do it again for g of x. Again, another word for for y is g of x, so that's my y. And I'm going to exchange my x and my y. So I've got x equals y cubed plus 2. Okay, so I want to subtract 2. So remember, I'm just undoing it in the order that I need to undo it in. So x minus 2 equals y cubed. So how do I undo a cube? Okay, so how do I undo a square? Square root, very good. So how do I undo a cube? Cube root, good. How would I undo a fourth power? Fourth root. How would I undo a fifth power? Fifth root. Yeah, whatever power it is here, I'm going to take that root, right? So I'm going to take the third root of that. And then if I do that to one side, I have to do it to the other side. Make sure it's a cubed root right there, right? So now the cubed root of y cubed is y, but I don't want to write it as y. I want to write it as g inverse. Now that I have y by itself, right? I can write that back as the inverse. And what does that equal? Well, that equals the cubed root of x minus 2. And I do want to say make sure that it's underneath my cubed root. My 2 is underneath there because that is one whole thing. So it's x minus 2. Sometimes you might have a problem where that negative 2 is outside the root. So make sure I can tell the difference between if it's supposed to be underneath the root or if it's not underneath the root. Make sure you can tell the difference, okay? And that's my answer. So there we go. We're going to go to the next page now. And we have another definition here. Okay. So my definition is a composition of function. So remember, composition of functions is what we did last time where we were putting one thing inside of something else. So this is a composition of a inverse. So I'm doing f of f inverse of x. And that has to equal x. Or I'm going to find f inverse and put f of x in there. And that equals x. So either I'm putting the inverse inside of f or I'm putting the function inside the inverse of x. And they have to equal x. If they're inverses, if they really are inverses, when I do this, when I put them inside of each other, each other, they equal x. If they don't equal x, they're not inverses of each other. Okay, so that's how we prove that if things are inverses of each other, we put them inside of each other, and if they equal x, they're inverses. So we have a couple examples of that, and here we go. So we're going to slide up here a little bit, and it says, let f of x equal x 2x plus 1 show that f inverse of x equals x minus 1 divided by 2. So how do I show it? Well, I'm going to use my definition that I just had. I don't want to slide up too much, I guess. I'm going to put either this in here, or I'm going to put this in here. I only have to do it one time. Okay, I only have to do it once. So I think I'm going to put f of x inside of, oops, yeah, totally messed that one up, didn't I? Okay, let's try this again. So I'm going to put f of x inside f inverse. So this equals f inverse of 2x plus 1, because that's what f of x is. Okay, so I'm going to, wherever there's an x in f inverse, I'm going to put 2x plus 1. So I get x, which is 2x plus 1 minus 1 divided by 2. Okay, so this is x minus 1 divided by 2. Okay, so here we go. So plus 1 minus 1 is 2x divided by 2. My 2's go away, and I get x. So are they inverses of each other? Yeah, we just showed they are because it equals x. That's all you have to do. Put one inside of the other. Okay? And then the next one, the next type of problem says, determine whether they're inverses of each other. So again, I'm going to do the same thing. I'm either going to put this in here, or I'm going to put this in here. Okay? One or the other. I don't have to do it twice. I just have to do it one time. So this time I think I'm going to do f of g of x. So that equals f of 1/2 x minus 3. So in f, wherever there's an x, so I've got 2 times 1/2 x minus 3 plus 6. So now I distribute. So what is half of 2? Well, that's 1x. And 2 times negative 3 is negative 6 plus 6. That equals x. So, yes, they are inverses of each other. Okay? So someone asked in the other class is if I could just find take one of them and find the inverse, exchange x and y's. That's not what they're asking here. They want you to determine if they're inverses of each other. That means I need to put them inside of each other and show that they equal x. That's how I'm doing this. Okay, so this is how you have to do it. If it says find the inverse, then I can exchange the x and the y, and then I can exchange the x and the y and find the inverse. But this says determine if they're inverses of each other, so I have to put them inside of each other and see that they equal x. That's the difference between the directions. Thank you. If you have any questions, please ask them in the discussion section of this area of this lesson. And if somebody can answer the question before I get there, please do so. And please be very specific in your questions. Thank you. Talk to you soon. Bye.